Very obvious cavitation on that top film, isn't there?
Mm-hmm.
It's got the classic findings. It's got that semicircular shaped lucency, nice fluid level. And what do we have to have for a fluid level? In order to appear radiographically, what do we have to have physically going on in the lung? Not in terms of pathology, but what has to physically happen? We have to have free air, free fluid, meaning those two things, air and the liquid, have to be in an open space. And they have to then be able to do what?
Come in contact.
Separate from each other. Separate from each other. Then we get this horizontal interface right here. So let's forget this one over here. This is another circular to oval, pretty well defined density, isn't it? It's a localized water density, semicircular shape lucency with a fluid level inside it. What's the wall thickness doing?
Thick.
That's thick, isn't it? Thick, fuzzy, or thick, more well-defined?
Well defined. Well defined.
This is very well-defined. This is very thick. Now, maybe it's a little bit thinner here, but overall, that's a thick wall. Wouldn't you say that's, I mean, it may be a slightly irregular and a little bit nodular, but this is still, you can pretty much define where this is. I would put that into the thick, lumpy nodular, well-defined inner, nice smooth outer. Definitely a thick wall cavity, isn't it? Now, if we didn't have this over here, then that becomes a solitary density, isn't it? And to be well-defined like that, that's most characteristic of tumor. But we got one over here, see it?
Mm-hmm.
We got one in each lung. One in each lung becomes multiple densities. Solitary means it's one in the whole chest. If there's one in each lung, it's now multiple densities. And what did they do 5 months later? Look at this one. And what's it starting to do?
Cavitating.
It's starting to cavitate. See the lucency in it right there? It's starting to cavitate. What did this one do?
Expanding.
The thing just kept growing. It didn't stop growing. The thing is growing and getting bigger and bigger, and it's still hollow inside, isn't it? Fluid level's gone because the thing's able to, it's been draining away. These are tumors, and this is metastatic disease. This was metastasis. You see this linear density right here?
Mm-hmm.
That linear density is a what's called plate-like atelectasis. It's also called a Fleischner line. Fleischner line. And we'll talk about those in class. They are the result of the diaphragm not moving completely. Okay?
Is this a female?
This is a female patient, and she had cervical cancer, which is squamous. And squamous metastatic to the lung also commonly cavitates like a squamous primary in the lung does. Squamous is the most likely tumor, mets or primary, to cavitate in the lung. And our last one.